This is the first in a series of tutorials where I describe how I made a wood projection shader. Now this block right here has basically two textures on it. It has a straight grain cherry normal map, diffuse and normal map. Which are these right here. And if I simulate this, you'll see that the texture acts as if it's a map to the object. There's no texture swimming or anything like that. So what we're going to do is we're going to start with another sample cube, which is this one I have conveniently placed right here. A simple wood material. This is the included wood pine and the normal map. Now I made a material function that has a texture object input, a world position, and it's masking off the red and blue channels and using that to project the world position to the UVs of the texture sample, which gives us this effect. When you move it around, the textures swim pretty badly. And the other thing you'll notice is a lot of stretching along the edges. So the first thing we're going to do is we're going to get rid of the texture swimming. So we're going to go back into our world position, our wood projection material function. We're going to get the object pivot point. And subtract the object pivot point from the world position. Now we're going to transform that from world space to local space. Let it compile, and our texture swimming is gone. Now we need to get rid of the stretching on this side. So what we need to do is we need to break the vector apart. Let's move all this stuff out of the way. And we need to get a projection angle. So we're going to add a new input for a scalar. Use preview. And add a preview value of 0.5. Now this angle will work from a value of 0 to 1. It doesn't work in degrees. So we're going to clamp it to 0 to 1. Now we need to add 2 multiply nodes. and one 1- node. Now we're going to multiply the red channel by our projection angle and the green channel by the inverse of our projection angle. And we're going to add them back together. And then we need to append these two to make a vector 2 with the blue channel. And we'll pipe that into the UVs. The scale's a bit off, so let's go ahead and add a scale to it. Add a new input. Use preview to true. I'm using a default value of 5. You can use whatever you want. Okay, now we're projected evenly around the box. Now you'll notice that, tell you what, let's go ahead and make a material function. It's a lot easier to display this kind of stuff with a material function, so because we can update it on the fly. Sorry, material instance. Okay, I created an instance of our wood projection material. And here's a texture scale parameter. And let's go ahead and add a horizontal projection angle parameter. Default value of 0.5. you'll notice that as we adjust the horizontal projection angle, the direction of the lines on the top of the block change. We're going to use that property to make rings. But before we do that, you'll notice that the grain is not running in the same direction as our lines. They don't quite meet up, so it doesn't look right. So first thing we need to do is we need to rotate the texture. Now there's two ways to do this. One is to take the texture out of Unreal and rotate it manually in Photoshop or GIMP or whatever. What we're going to do is we're going to rotate it in the material. So in order to rotate this, first we're going to need another input, because we don't want to do this every time. It's going to be a bool, and it's going to be (90°). Rotate texture 90°. Use preview, and we're going to add a static bool with a default of false. Now after we have our appended vector, we are going to break it back apart. And we need to switch. We need two static switches actually. Okay, and let's break this link. So the red is going to go to false on the top switch and true on the bottom switch. And the green channel is going to go to the opposite of that. True on the top switch and false on the bottom switch. Our Boolean is pumped into value. And we get another append vector. So basically we're just swizzling the values if this Boolean is true. So we'll add another parameter. Static bool parameter. Now connect the rotate texture to the rotate texture input, save it. If we go to our material instance and rotate our texture, you'll see that it all lines up now. Let's scale it up a little bigger so it's obvious. And you can see that all of the lines in the texture match the lines in the top. Now to make a circular end grain of the top, we're going to need to another input. And this one is also a Boolean, because we might not want the curved end grain every time. Use preview. Add a switch. Let's change that to use curved end grain. So if use curved end grain is true, then we want to use the curved end grain, which this is not, so we have to disconnect that. And we'll use the straight end grain when use curved end grain is false. So here's the tricky part, how to make a curved end grain. To do that, we have to use the formula for a circle. First thing we're going to do is we're going to add another input, and this one's going to be a vector 2, and this is going to be circle center offset. With a default of 0, 0. Okay, we'll put the formula for a circle in our comment box so we know where we're going with this. Break apart this vector. Now we need to add, and we need 2 add nodes. And these are connected to our outputs up here. And we add these together. And I put the switch in the wrong place. The switch comes after this append. This append is connected to the breakout float. The blue channel is always connected there. So we'll add another Boolean. And that did not work. I completely forgot to incorporate the entire circle formula. So we add power node. we go. Circular deformation. Now we also have an input for the circle center, which we need to label properly. A circle center offset. So now we can go into our material instance, and this should only work on the red and green channels, and offset where the center of the circle is. And that'll be it for this video. In the next video, I will get into how we add a little bit more wood-like grainy look with the distortion around the circular grain. And we'll deal with scale correction and a couple other things.